All right, problem 8-47. It says, are the intercepts enough? Melvin wrote the equation y equals the quantity of x plus 3 times the quantity of x plus 1 times the quantity of x minus 2 squared to represent the graph at right. Letter A, explain how you can decide whether the equation represents the graph. What can you do to the equation to make it a better fit for the graph? What equation would fit better? So as we look at our graph, right? So he said that we had a root there at -3, which is where Melvin got the x plus 3 as a factor. He has a root at -1, so that's where he got the x plus 1, and both of them are passing straight through. And then over here, he's got x equals 2, so the factor would be x minus 2, and since it's bouncing, he's got it squared. So that all looks good, right? And it's got a positive orientation. So far, based on the root behaviors, that looks pretty good. But let's test it with a point that's not a root value like you did on the first problems on 8-45. Okay, so let's find a good point to use, right? And, it's kind of hard sometimes to figure out, like, hey, what's a good point? We want something as clean as possible and as accurate as possible. So let's see. If I don't really see something good here, I would say maybe just try this y-intercept. Okay, when I look at that y-intercept, it looks to me like, I don't know, that would be something up in the 20s, right? It's between 20 and 30. So before we, worry about what the output is, let's just plug in 0, right? So that's what we're going to do. We're going to plug in just 0 to see what the output will be. Okay, so we're going to plug in 0. So here's Melvin's equation. We have y equals the quantity of x plus 3 times the quantity of x plus 1 times our quantity of x minus 2 squared. And when I take it and I plug in 0, right? So I'm going to do just like f of x or f of 0. I'm going to say 0 plus 3 times the quantity of 0 plus 1 times the quantity of 0 minus 2 squared, which is going to give me a 3 times a 1 times a -2 squared, which is 4. And you'll see we get 12. When I plug in 0, I get 12 out. But when we look here at this point up here, this point is definitely more than 12. If I was going to estimate now what it is, right? So I have 20 here, this is 30. Maybe would it be a good estimate to say that that looks like it's about 24? This is the point 0, 24. So if when we plug in 0 into the function or the equation that's given, and we get 12 out, what would we need to do to that 12 to turn it into this 24? What would that extra stretch factor need to be? Right? So we need to have like another factor maybe right in here that does not have an x, right? So what if we took it and we put like a stretch factor of 2 in? Would that work? Right? If we just did, and let me undo what I was writing right there. Let's say if we did f of 0 equals, and we put this 2 in first, right? We had that 2 in there, and then we did our 0 plus 3 times our 0 plus 1 times our 0 minus 2 squared. And now when we're figuring out what this side would equal, we'd have 2 times a 3 times a 1 times a -2 squared would be what, 4? And now when we multiply that all together, we get 24, and it fits our graph a little bit better, right? So this part was missing. So I think that, if we had that extra stretch factor in there, it would definitely fit better. It would be like saying y is equal to 2 times the quantity of x plus 3 times the quantity of x plus 1 times the quantity of x minus 2 squared, right? So we added that extra stretch factor in. Now let's look at B. B says before you figured it out, you could have written the polynomial for this graph as p of x equals a times the quantity of x plus 3 times the quantity of x plus 1 times the quantity of x minus 2 squared. It says, what if you did not have a graphing calculator, but you were told that the graph does go through the point 116? How could you use that information to determine the exact equation? It says, once you have decided on a method with your team, try it. Okay, so here's the method I think we're going to try. So if we're thinking about this same equation, and they're using p of x, I know I use like f of x above, not a big deal, that doesn't matter. But if we think about this point, 116, right, we have an x and a y, right, or an input and an output. So if we plug those in, if our output, right, if we think about this like it's y, if I put my 16 in, I don't know what a is at this point, so I'd leave it like that. And then I would take it and I would plug in my 1 for my x's. So 1 plus 3 times 1 plus 1 times 1 minus 2 squared. Now we'll just look to simplify the right side, right? I'm going to have a times 4 times 2, and then 1 minus 2 is negative 1, and negative 1 squared is 1. So 4 times 2 times 1 is going to be 8, so I have 8a is equal to 16, and if I finish solving it, it actually helps me to figure out what the stretch factor would be. So I get a is equal to 2. And then I could take it and I could replace this a with the 2, and I have my equation, right? It would have been p of x is equal to 2 times the quantity of x plus 3 times x plus 1 times x minus 2 squared, which is like what we have up here.